All right, it is time for another fun edition of math videos. This is 5-3, also on the quiz. So this is adding and subtracting. Some of you got confused and did every single problem as multiplication. You have to look at and see what the operation is, meaning what math are you doing. If it's a negative, like this is subtraction, it's like you have a -1 that has to distribute to every single thing after it in the parentheses. So I have the 6m to the third minus the 5. Then that -1 turns this negative. Same with the 4m squared. But the negative multiplied by this negative makes it a 9m. And the same thing happens here. This negative with the -2 changes that to a positive. Then you go through and collect like terms. Highest power first. So I'm looking for the highest power, which turns out to be m to the third. And if I have 6 of them minus 1 of them, I get 5 of them. Now, when you're doing adding and subtracting, you never change the powers. They never will change. You're just collecting the ones that are the same. Then you move on to anything that's the next power down. So in that case, that's a m to the second. And there's just that 4m to the second. There's nothing to work, like to combine with that. And then you go back looking for the next lowest power. So if it was m to the second, you'd be looking for m to the first. But all you get there is 9m. And then the very last thing I'm looking for is the ones that don't have an m at all. They're to the, like they're constants. And in this case, that's going to put me with a -5 plus 2, so I get a -3. And if you collect like terms from the highest to the lowest power, it ends up in standard form like it should be. Over here, it's even easier because it's a plus sign. You're not going to multiply, you're not going to change the powers. So no changing the powers when you are adding or subtracting. You are just collecting like terms. And in this case, I don't even have to do anything because it's like having a +1, but multiplying everything by +1 doesn't actually change it. So I go on my hunt for the highest power of q, and in this case, it looks to be to the third power. So I'm going to have a -3 minus 8 more. So use your calculator if you're feeling like you're not very confident about that. So -3 minus 8 more is -11q to the thirds. Next power down should be to the second. So I find any q to the seconds. And it looks like I just have that 5q to the second. Nothing combines with that. Then I go back hunting for just plain q's. There's 1 here and 1 here. So I have 7 q's minus 1 q is going to leave me with 6q. And then, which is different than the answer key I'm seeing online, she has 8. Then I'm looking at numbers, and the only number I have is the 16. So then I have 16. So again, if you started with the highest power, it's already in standard form, and you don't have to worry about that at the end. Okay, now it says find the product. When you're finding the product, you're going to be multiplying. When you're multiplying, you're going to change the powers, just like we learned back in 5-1. So this is on the outside. I'm going to multiply this. I'm going to write a 1 here so I don't forget. 2 times 5 is 10, like it has been since elementary school. And x to the third times x to the 1 makes x to the 4 because I end up with 4 of them all together, like in the very first problems. And then here, 2x to the third times the -1 is going to be -2x to the third. No, there's nothing to combine. I'm good to go. This is the one that I talked about at the beginning of the first video. I do have a power on the outside, but I can't distribute it because it has addition in it. Back in the very beginning, zoom, 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 of the review, if I had a power on the outside like here in number 6, I could distribute it because these are all multiplied together. But now that we're into this 5-3 business, I have addition in there. So this is the one where I said you have to go ahead and just multiply that by itself. That's what squaring means. Then you're going to need to FOIL it. And if some of you can't keep track of FOIL, you can do a chart. Whatever makes the most sense to you. So this turns into 16t to the second because I have a t to the first and another t to the first. Then I have a 4t then this inside becomes another 4t, and these become a plus 1. So these will typically combine. So I get 16t to the second plus 8t plus 1. Now, if you like that chart method, you can go ahead and write the 4t plus 1 up the side and a 4t plus 1 down this side. I'm at top. So then in this first box, I'd be taking this 4t times this 4t, and I'm going to get 16t squared. Then I just keep kind of working my way across. I'd be taking 4t times 1 and get 4t. Bottom row, I'll be taking this top 4t times that bottom 1, getting myself a 4t. And in the last corner, I'm always going to get a number. So 1 times 1, and that's going to give me 1. And like usual with this, these diagonals are alike. So I start up in the top left with my highest power. Then I combine these. And then I end with that constant in the bottom right corner. And these are going to be the same because they're just two different methods for doing the same thing. Okay, and more of you, I think, were using it for these bigger problems. So I'm going to take my 2n squared, a negative n, and a negative 7, put those across the top of my chart, and then I'm going to have my 1n plus 5 down the side. So it's just as easier to keep track. And keep in mind, I'm only doing this when it's multiplication. So in this first box, I'm going to go ahead and take the 2n squared times the 1n and get 2n cubed. Here I'm taking my n, negative n times my positive n and getting negative n squared. And in this last box, I'd have negative 7 times n. In this bottom left corner, I'm going to be taking these two to get this box, and that's going to generate 10n squared. Here I'm going to be looking at the negative n times the 5, and that's going to generate a negative 5n. And in the bottom right corner, I'm going to do the negative 7 times 5, so negative 35. And then these diagonals should combine. So when I start on my top left corner, I have my 2n cubed. The next diagonal, I have a 10n squared minus 1n squared. So that's 9n squareds. Then in my next diagonal, I have a negative 5 minus 7 more, so negative 12n. Keep in mind that in this stage, I am not changing the powers. I'm just collecting like terms. And then the bottom right has a constant of negative 35. What did I miss? Okay, so then that's the end of 5-3. The next thing we did was 5-4. Actually, these are backwards because technically this next thing was 5-5. And then the last thing was factoring. Now, I am going to eliminate this because I didn't teach it to you in the notes, and we're not going to have one on the test, so we're not going to do it. So I'm actually going to go in order. I'll come back to these two. First, we're going to do 5-4, which was factoring. Okay, so we've talked about factoring a lot. It's based on always looking for the GCF. They've got to check first, the greatest common factor. And then it depends on how many terms you have. If there are 2 terms, the only way you can factor it is if it's one square minus the other. And it will always break down into the sum and difference of the square root of each of these things. So there has to be subtraction and they have to be squares. And then if it's 3 terms, you still don't have any choices. You have to unfoil it, and that's going to be where you use the yellow card. You're looking for like the number pairs that work. Or it has 4 terms, and you use grouping. Now, a lot of times with grouping, you end up getting to factor it more, but we can see if that pops up here. So in this first problem, like I look and I go, oh, there's 3 parts. So I'm going to ultimately have to unfoil it. But first I see if there's a GCF, and there is. They all have an X. You can only take out however many x's the least guy has. So in that case, that's x to the first. When you take out, when you take out an x from here, you're left with x squared. From here, you're left with x. And from here, you're left with minus 20. But, choking part of the video, you now have to use your yellow card to see if there's a way to break up 20. So look at your card. But you need to break up 20 in a way that subtracts to be this middle one. So 4 and 5 work. So then I'm going to need to go ahead and break that down further. I still have my GCF out front, but now I can break down my x squared plus x minus 20 into a 4 and a 5. And in order to get a positive 1, I'll need a positive 5 and a negative 4. So this is simply saying to factor. So I stop there. I don't have to go ahead and find the zeros. If it asked me for the solutions, or it asked me for the zeros, then I would go that next step and say, oh, that means x could be 0, which makes this 0, 4, which makes this 0, or negative 5, which makes this 0. But this particular part of the worksheet doesn't ask that. So you're welcome for doing that extra work. Okay, and then here, I'm going to take out my greatest common factor. Looks like the biggest number that'll come out of this is going to be a 2, and the most x's I can pull out of it is also 2, because otherwise that guy in the end is going to run out. So when I do that, that will leave me with a 6 here and 2 leftover x's. 10 divided by 2 is going to leave me with a 5 there and 1 leftover x. And then 8 divided by 2 is going to leave me with a 4. And since I divided out all the x squareds, that's all I have. So then this one has 3 parts, so I have to double check and see if I can break it down. If I'm going to be able to do that, remember I always use that kind of working on making it bigger to work on it and then shrinking it down. So I put a 6 here and here for now. And then the number that I look to split up is the front times the back, so 24. I don't care about plus minus. So I look at my chart for 24, the yellow card, and I'm looking for a pair of numbers on that yellow card by 24 that subtracts to be 5. So if you look through the number pairs, the one that subtracts to be 5 is 8 times 3. So I'm going to use an 8 and a 3. To get a negative 5, I need negative 8, positive 3. But then I have to reduce. Keep in mind, don't lose this guy. He's your GCF. You got to keep him. This one can divide by 2. This one can divide by 3. So when I'm done, I have the 2x out front. That was my GCF. This will reduce to 3x minus 4. And this will reduce to 2x plus 1. And that is all I have to do because the directions here say to factor completely. Okay, so this one I'm looking at it and I'm seeing that it has 2 terms. So I'm going to do what I always do and pull out the GCF. This is my limiting term right here. There's no other numbers that come out. So I take out that x squared. That would leave me with 2 x's in the first term and just the 49. But now you have to look back and say, oh, this has 2 terms. Are they both squares that are subtracted? And the answer is yes, because this is the perfect square of x, and this is the perfect square of 7. So using my factoring pattern for that, I keep my GCF. You never want to get rid of that. And then this would split into x plus 7, x minus 7. And then I'm done. Whoa, okay, 4 parts, there's no choice. I have to do grouping. Okay, so I'm gonna go ahead and do that. I take the GCF out of each side. So on the left side, I can pull out an x squared, leaving me with x minus 3. On the right, I always keep the sign, so this one's a plus, and the number or the thing that goes into both is just a 6. When I divide it out, this becomes 1x. And here it becomes a 3. That's good because these two have to be the same. That's how grouping works. Because then those two come out front as one of the factors. and these two become the other factor. Now watch that second one pretty closely because sometimes you can split it up more, but it's two terms. So the only way it splits up is if it falls into this pattern. Otherwise it can't factor. And it can't factor because ours isn't two squares that are subtracted. It's two numbers. 6 isn't even a square, but they're added. So there's no way to break that down anymore. And these are my final factors. It doesn't break down further. Okay, so here's asking for the real solutions. That means we have to find our zeros, but you still have to find the factors first. That's how we're doing this. So I'm going to go ahead and I'm going to find my GCF, which is going to be an x squared, leaving me with 1x here and then a minus 5. In order for that to be 0, I look at what would x squared have to be for it to equal 0? And the answer would be 0. And then here, I'm wondering what will x minus 5 give me as an x value? Like what would I have to plug in for x to make that equal 0? And the answer is 5. So then these are my two solutions or zeros. This one is not equal to 0 and I need it to be. Before you can find zeros, they have to be equal to 0. So take that negative 4x to the 5th over to the other side, and then I'll have a 0 equation. Now I'm going to look and see what my common term is, and my greatest common factor is a 4, and then I can take out 3 x's. When I do, this first term is going to become a 25, and then minus here, the 4 will come out and 3 of the x's, so I'll just have an x squared. But always watch that because this is pretty suspicious. This one falls into that pattern. This first part is the square of 5, and the second part is the square of x. So I'm going to go ahead and break that down further. 4x cubed, and then this will be 5 minus x and 5 plus x. So if you think about what makes 4x cubed equal 0, x will have to be 0. I wrote these kind of funny and backwards, but in the end here, for this to be 0, I'd end up, I'm going to move that x over to the other side by addition. And so it's basically like 5 minus what is going to be 0. So my answer is 5. Here, 5 plus what will be 0. Well, that'll only work if x is negative 5. So these are my factors. These are my zeros or solutions. This has 3 parts, so I'm going to unfoil it using my yellow card, but first I'm going to see if they have a common term. They have x squared is the most I can take out. Here, if I take out 2, it'll leave me with 2. Here, if I take out 2, it will leave me with just 1. And then it's yellow card time for this business. I look at my 27. I don't have to do anything with the number in the front because it's a 1. So 27, you don't have a lot of choices. These are your choices. And what I'm looking for is a pair that also adds up to 12. So 3 and 9 are going to be my numbers that work. So I have my x squared floating in the front. I have my 9 and my 3. It doesn't really matter where they go. And then now I look and go, okay, how will I get a positive 12? And that'll only happen if they're both positive. So these are my factors. Well, what if it wants me to find my solutions or my zeros? Which it does. So I look and see what would make x squared be 0. Well, only if it was 0 squared. What would x have to be here to make that equal 0? And the answer would be negative 9. What would x have to be here to make that equal 0? And the the answer is negative 3. So these are my solutions or zeros, which is what it's asking for in that section. And zoom, zoom, zoom. We don't have to do that. I did skip 5, 5, so let's go back. These are the only two things. We did where you divide by one term or where you divide by a plus minus. So let's look at both. In the end, you factor them all. You always just factor. So in the top, we're going to take out the GCF, and then we're going to reduce it with the bottom. So looking at 15, 12, and 3, 3 is the biggest number, and then the most x's I can take out is this guy because he has the fewest to give. So if I take 15 and divide out the 3, I'll be left with a 5. If I had x to the 6 and I took out 3, I'll be left with 3. In the middle, I've got a minus, and then if 12 is divided by 3, it'll leave me with a 4. And if I had 4 x's and took out 3, it'll leave me with 1. And then here, if I have 3x to the third and I divide out 3x to the third, everything cancels, so I get a 1. Then I put my common denominator, I put the bottom back in. Like I ignored this the whole time. This is just the GCF. These cancel entirely, so that just means that I don't have the bottom anymore, and this is the answer. It went in evenly, like everything else is gone. Over here, grand finale, this is a 3-part top, and it's one of those where there's a number in the front. So I'm going to have to factor it by putting a 6 here and here for now. Multiplying these together, I get a 12. So I go to my card, and I'm looking for, oops, I forgot 2 and 6, a pair, but I also need them to subtract to be 1. So 3 and 4 are going to be the numbers that I need. In order for it to be a positive 1, I'll need a positive 4 and a minus 3. So for right now, I'm totally ignoring this. I'm just working on the top. I can reduce this by 2, and it'll become 3x plus 2. I can reduce this by 3, and it will become 2x minus 1. And then once I factor the top, I go back and grab that bottom, and then any factors that are common to the top or bottom cancel, and whatever's left standing is my reduced fraction or my division. So that's a lot to keep track of, and so that's why I kind of broke it into 2 days. Look over your quiz, look over the videos, get your red card ready so that you can be awesome. Have a good night. Bye, guys.